Today I will be doing a technical seminar on an optically driven digital metasurface for programming electromagnetic functions. Under the guidance of Dr. Narayan K, PhD, Dean R&D, Professor and Head Department, EC SVIT. So I extend my sincere thanks to Professor Y. Jayasimha sir and Professor Dean Academic and Professor Department of ECSVAT. I would like to acknowledge Dr. Narayan K. Dean R&D and Professor of Department of ECSVAT. I would like to acknowledge Professor Vikramadityan, Professor and Deputy Head of Department of ECSVAT. I also extend my sincere thanks to Professor Chaya PM, Associate Professor, Department of ECE, SVAT, for her timely advice and encouragement. I also extend my sincere thanks to Professor Suryanarayan NK, Assistant Professor and Technical Seminar Coordinator, Department of ECE SVAT. So the contents of the today's seminar is introduction, principle, design and implementation, methods, results and conclusions. So going to introduction. So what are metasurfaces? So metasurfaces are engineered surfaces that consist of subwavelength periodic elements which are used to manipulate electromagnetic waves. So these meta devices consist of bulky power supply and other FPGAs with electrical wires and complex control circuits. And are based on direct current biasing systems. So to overcome these bulky power supply and FPGAs and electrical wires and complex control circuits, we use digital metasurfaces. Digital metasurfaces, which are also used for manipulating electromagnetic waves. So this digital platform has 6x6 subarrays, each of which contains 4x4 meta surface elements. So these digital meta surface is used for external clocking, illusion, and dynamic vortex beam generation. So these are all electromagnetic functions. When there is a optical interrogation, the digital meta surfaces becomes optically interrogated a digital platform, that is OIDP. So OIDPs are compact and portable. So this overcomes this overcomes the bulky power supply FPGAs and electrical wires and complex control circuits. This is a small figure representing OIDIP architecture, and these are meta surface elements, and these are diodes, pin diodes. Next, coming on to the principle. Okay, the OIDP consists of 6x6 subarray, each of which contains 4x4 light addressable subwavelength metasurface element ME integrated with optical interrogation network OIN based on pin photodiodes. This how OIDP works is that light is projected onto back of one of subarray. The OIN will convert. OIN means optical interrogation network. Optical interrogation network converts illumination into different voltage and are fed into metasurface elements. Next, the resonant state of these MEs can therefore be tuned remotely. Each subarray can be controlled independently under different light patterns. So this makes the MEs, that is meta surface elements, to also get programmed according to our needs. So OIDIP can be programmed to generate various reflection phase distribution, which creates different EM functions such as external clocking, microwave illusion, and dynamic vortex beam. So these are the EM functions, that is external clocking, illusion, and this is how the light is fed to the digital OIDP, that is optical interrogated digital platform. Next, coming on to the design and implementation. Metasurface elements are designed with low quality factor, a low quality factor that is called as Q factor. Then the metasurface elements contains two metallic layers. Two metallic layers. Top metallic layer is composed of is grounded and to enhance retro reflection. So due to EM waves, the metallic part can be modeled as inductor, and it can act as capacitor also. So this becomes a RLC circuit. So here the word resonant frequency arises. Vector diode is used to tune effective capacitance. Vector diode should be chosen of low ohmic loss, and should have high tunable frequency with wide range frequency band. So the Q factor decreases when resonant frequency increases to high frequency. That is, when Q factor decreases, decreases with respect to the frequency, high frequency. So coming on to OIN. So OIN is optically interrogated network. This is in this topic they have used BPW 34S silicon pin photodiode from Osram, that is company, used as light sensor due to high switching speed, easy integration, sensitivity is more, and maximum voltage by the photodiode is about 0.5 volts, and BPW thickness and length and width of BPW 34S silicon pin photodiode is approximately 6.7 and 400 mm. 6.7 mm and 400 mm. So the slide length of metasurface element is about 10 mm. Next, 4x4 identical MEs is combined to construct a super unit cell with the wavelength scale. Next, this figure shows a part of a metasurface element, and as I had already told that RLC circuits, that is, it gives a resonance frequency. And here are some of the graphs. This is reflection phase with respect to frequency, and reflection amplitude with respect to frequency, and Q value with respect to frequency. So in this reflection phase, this is measured in degrees. So the capacitance increases with respect to the frequency increase, and reflection amplitude is measured in dB, that is capacitance, total capacitance value yeah, increases with respect to the frequency increase, and whereas the Q value with respect to frequency decreases, the capacity decreases. So next. So coming on to methods. Coming on to the methods. So as I already told that it is a RLC circuit. So we'll be finding Z effective, that is impedance effective, that is R effective plus imaginary of 2 pi f L effective minus 1 by 2 pi f C effective. So the cutoff frequency is 1 by 2 pi root L effective C effective. So we know the output power, the output voltage of the photodiode is ND VT Ln IP EV divided by IS plus 1. So this ND represents ideal factor of diode. VT represents the VT represents 0.06 volts, and IPEV represents the photocurrent generated. Then IS represents the reverse saturated current. For simulation of these electromagnetic functions, that is that is external clocking, illusion, microwave illusion, and what is it? Vortex beam generation. We will be using this formula, that is phi re is equal to 2d divided by 360 degree by lambda naught, that, and phi ob minus n into 360 degree, where n is equal to 0 plus or minus 1 plus or minus 2. So what is the phi re means? Phi re means reflection phase. Phi op means reflection phase of an object, and the lambda naught is wavelength. Wavelength at free space. So for external clocking, lambda naught is equal to 51.7 mm d, and distance is 34.5 mm. Phi observed reflection phase of an object is 180 degree, and for n is equal to 2, to achieve phi re is equal to 40 degree. The corresponding capacitance taken is 0.17 picofarad at 7 gigahertz. For illusion, for illusion, capacitance values for metasurface is set to 1.15, 0.4, 0.29, 0.14, 1.15, and 0.4 picofarad respectively. The phase difference between two adjacent regions is 90 degree at 6.5 gigahertz. For vertex beam generation, metasurface elements with different capacitances, that is CT is equal to 1.15, 0.4, 0.29, and 0.14 picofarad. So as we need to program the metasurface elements, the light source is necessary. A light source in the form of an array, that is 6 cross 6 identical light emitting diode spotlights, with each spotlight controlled by a knob adjusted with the voltage regulator. So for excitation of metasurface, we are using a horn antenna with a gain of 15 dBi from 5.38 to 8.17 gigahertz is used as primary feed. So these are programmable metasurfaces and optical interrogation networks. Next, this shows the experimental setup of metasurface and light sources, and this is the feed on, and this is the sample. What will be giving as light source. Next, these are the results obtained from the experiment. So this is unclocked and clocked, and this is illusion, and this is target. So illusion will resemble the target, and vortex beam generation. That is, vortex beam generation is vortex beam generation is yeah. Vortex beam generation is the zero, is the point at which the zero of the optical field is present. So this L is equal to 1 and L is equal to -2 are the modes of vortex beam generation. So these are the graphs obtained with respect to electromagnetic functions. That is, the blue line, the green line indicates the unclocked sample, and the red line indicates clocked sample. And coming on to the next graph, this shows the object, and this black dotted line shows the object, and red shows the illusion. Next, coming on to the vortex beam generation, that is that is the red line shows the simulated one, and the dotted black line shows the measured one. So concluding the seminar, ultra compact OADAP consists of 36 OANs, each of which independently controls 16 broadband metasurface elements by illumination intensity. So metasurface elements can achieve an accurate 180-degree phase difference with a wide frequency range, and also can be extended till 260 degrees. Programmable metasurfaces in microwave band to demonstrate several functions, combining customized control and computing programs, as well as executive circuits and other software. These self-adaptive programmable functions can be used for next generation wireless systems. So these are the references what I have used. Thank you. This ends my presentation.